Hello, everyone. This is a quick introduction to a concept in HL7 FHIR. It's called HL7 profiling. And so you're going to want to remember this word profiling because it's absolutely critical in making interoperability work in healthcare today. All right. There are three components of interoperability, and you need all three components for healthcare data to go from any one system to any other system. We're going to talk about transport. How do you move the data from one system to the other system? Especially, how do you move it securely? We're going to talk about the data model. What defines a patient? What defines a CBC, a complete blood test? How do you transport that particular information? And then not most importantly, equally as importantly, what is semantics? How do you define what a complete blood test even means? How do you define what a heart rate means? How do you interpret it? So you need all three things. You need to know how to transport data from one system to another system. You need to know what the components of the data are, and is it represented as a number or a text string? And you need to know things like when we talk about heart rate or when we talk about any particular genome, let's go to genomics for a minute, that can get really confusing. You need to understand the semantics about what each other is talking about. So transport, when we're talking about a standard such as HL7 FHIR, we're going to be talking about things such as HTTPS, where it's secure. Anytime you use any browser on the internet, you are using HTTP and probably HTTPS. You're going to hear things called OAuth and single sign-on. Those are all parts of security in the internet. You're going to hear about application programming interfaces or APIs. Maybe you've used Postman in the past. You might hear about CRUDs, which is create, read, update, delete. Hopefully we don't delete any medical data. We're going to deprecate it and hide it maybe if it's wrong, but we're not going to delete it, or you're going to have a lawsuit on your hands. And search. So you're going to hear about APIs, application programming interfaces, and you're going to hear about CRUDs, create, read, update, deprecate, and search. In data models, you're going to hear about things such as, like, what are the different elements that define a patient? What are the different elements that define a physical location? What are the different elements that define a piece of equipment? How about a surgical note? Those are all things that go into a data model. Those are defined in HL7 FHIR, what are called resources. And I think you've seen those already, but we're going to take a look at them again. And then finally, you have what is arguably the hardest part of it, which is semantics. What are you talking about? Especially when you get into something like healthcare, all of the data gets really confusing and really complex really quickly. We're going to look at ontologies. Hopefully, you've heard of LOINC. LOINC is an ontology which has all sorts of definitions of different terms. We're going to talk briefly about USCDI. US is United States Core Data Interchange. And we're going to talk about how USCDI defines something as simple as what is a patient? What is a lab value? You may think that that's easy, but actually it's really hard. US Core. US Core takes, US stands for United States, one more time here. Core takes the USCDI list and says, hey, if we're going to use this list of data up here in USCDI, and we're going to combine it with FHIR resources that we're going to transport, then let's get way more specific and take this data and talk about exactly how we're going to transport it. So this is kind of where the rubber meets the road. USCDI is a really good list. US Core makes it happen. And how we can make it happen, we're going to make it happen with FHIR profiles. So the entire purpose of FHIR profiles is don't let garbage in. You're going to take a look at this later. But if you let garbage into your EHR, you're going to get garbage out of your EHR and any other medical system that you've got. So the whole point of profiles is don't let garbage in. So I talked already about these three components of interoperability. And so let's go through that one more time. LOINC is a list of ontology. This is semantics only. USCDI is a really good list of data, but it's just a nice list. US Core, this is how we're going to define it. This is no more messing around. And profiling, this is where we really ensure that there's no garbage in the EHR. So let's end this for a second and switch gears here a little bit. Okay, the first thing we're going to do is we're going to go to FHIR. So how do you get there? You type in FHIR. R4, because that's the version of FHIR that we're going to use. There's lots of version numbers. Everything has its own version number. We're going to go to FHIR R4 resources and take a look at the FHIR R4 resource list. So this is everything which is defined by a standard called HL7 Fast Healthcare Interoperable Resources. There's lots. There's just so much. But healthcare is really complex and it's really important because there's a lot on the line. If you mess something up, you've got a patient life at stake. Let's go take some look at something relatively easy. Let's just look at how they define a patient. Okay, we're going to scroll down here. This is called the schema. Here's the object or the resource, and here are all of the elements. Let's take a look at some of the elements in here that define a patient. You've got name, that's good. Telecom is everything from email to telephone number, gender, date of birth, whether or not they're deceased, that's always good to know. Their address, marital status, whether they're a twin or multiple birth. Sometimes they put a photo in here because it's really helpful. Contact information. What is their primary language? What is their preferred language? Who's their physician, the practitioner? But there's something I want to show you in here is these different columns. This is the name of the element. This is cardinality, or whether or not it's required. We'll come back to this in just 1 second. Here's the type. Here's how you say, is it a number? Is it a text string? And here's some more information about it. But there's something specifically I want to show you when we're talking about the data model in FHIR. You will notice 0 to many. It means you can have as many identifiers as you want. Let's give another one. You can have as many names as you want. You can only have one gender. This is the administrative gender. You can only have one date of birth. But you'll notice that it's 0, date of birth is 0 to 1. That means you don't have to have a date of birth. You don't have to have a phone number. Good luck getting hold of people. You don't even have to have a name. And actually that makes a ton of sense, right? Because if you come in through the ER because you were out hiking and somebody had a heart attack, maybe they don't know their name. If they're unconscious, they don't have a patient name, as odd as that may seem initially, and they're not going to have a date of birth. But in general, with the exception of an unknown patient, you're going to want to have dates of birth and names if known. So you can see how for the use case, for most use cases, there's nothing, virtually nothing required in here. As a matter of fact, I'm scrolling down, I don't see anything. So you can have a patient with absolutely 0 information with the exception of the computer identifier. So this identifier is like a medical record number. There's a unique computer record number that's required, but otherwise there's nothing required for a patient. Seems kind of strange, hey? But it's true because it depends on the use case. And FHIR defines the 80-20 rule. Now, let's keep going in terms of data. Let's go type in USCDI. We're going to ignore the AI overview. Feel free to read it. I'm going to jump right down to the real list. USCDI is published by Health and Human Services, often known as HHS in the United States. There's a subgroup of Health and Human Services called ASTP, or Assistant Secretary for Technology Policy. That's really important because it's technology and policy within Health and Human Services. There's a lot within Health and Human Services. USCDI stands for United States Core Data for Interoperability. We're going to scroll down a little bit here, and you can see all these different versions. It started out really small. Version 1, it defaults to version 1. Be careful not to look at that. Version 2, version 3, version 3.1, 4, 5, 6, and draft. We're going to go to draft because it's the most recent. You'll see the new draft ones will have this little new tag on them. Let's go back down to our patient. Okay, so down here we have patient demographics. We have a first name, a last name, a middle name, date of birth, date of death, race, ethnicity, tribal affiliation, sex. You'll notice it's just a nice list, right? It's just a nice list of data. If we are using HL7 FHIR, we can use this list. If we are using HL7 version 2, which is an ancient but very often always used standard within healthcare, we could use this list. If we're using DICOM for images, we could use this. So there's all sorts of standards in healthcare. And so they want you to use one list, which at least you're starting at the same point of what defines a patient. That's a good thing. So this list is really helpful, but it's insufficient, woefully insufficient. Let's go down and look at some more. for interoperability. But let's go down and look at some more things. Vital signs down here, these are the things that define what the United States government feels is important for vital signs. Vital signs is systolic and diastolic blood pressures, heart rate, respiratory rates, body temperature, body weight, height. Pulse ox is they stick the little thing in your finger and have the infrared light to see how much oxygen is in your blood. So these are examples of vital signs. Again, it's a really nice list, right? Everybody should start with at least with the same list of what are vital signs. That's great. But again, woefully insufficient. Necessary, but insufficient. Now, let's go to US Core. Whoops. US Core FHIR R4. We're going to click on this one. Now you'll see this is at version 9. I can't remember what that was, version 7, I think, draft version 7. This is at version 9 because all of the different pieces of information have different version numbers so that they can grow at different rates. And that's a good thing, but the version numbers can drive you a little crazy. The one you really need to remember is FHIR R4. We're going to just scroll. You should feel free to come back and read all of this. Now, here's where the rubber hits the road. We're going to take the FHIR resources, and we're going to take USCDI, and we're going to take one more thing, which I'm going to touch on really briefly, called LOINC. LOINC is a search. I'm going to go to search.loinc.org. LOINC is an ontology. So it is not United States specific because there are people everywhere. It's just a list of medical terms. I'm going to type in kidney. And look, here's all these things to do with the kidney. So it has a LOINC code, which is unique when combined with the word LOINC. LOINC 85596-5 means preferred kidney failure treatment if kidney disease progresses to kidney failure. It doesn't mean anything else, and you cannot find another code within LOINC that has that number. It will always have that meaning. You can click on these, and it will go into a lot more detail about all of the different things. Feel free to pick. Oh, here's an interesting thing. Here's how you say this in Greek. Here's how you say this in Spanish. Here's how you say it in Italian. And here's how you say this in Chinese. The reason that that's so important is because there's these things called global health. For example, like a recent one was called COVID, where infections and viruses do not stop at global boundaries. And so you have to compare data worldwide. And so you want to be able to read these things in your own native language. And so it's translated to, actually, LOINC is translated to, I think, 50 languages. So this is LOINC, and I'm going to go back to US Core. All right, now US Core is where the United States government takes this list of USCDI preferred data and applies it using FHIR R4. That's called FHIR profiling. When you take FHIR, even though everything is optional in FHIR, and you take this nice list and you say, now we're going to use codes like LOINC, and we're going to make this very specific so that interoperability can actually occur. Let's go down and look at a patient. We'll come back to some of these observations in a minute. Okay, we're going to scroll down. There's lots of good information in here. You should read it. I'm going to scroll down to the structural definition of a FHIR profile. By the way, absolutely anyone can make a FHIR profile. You can make a FHIR profile if there's something you'd like to profile. The United States government is trying to make the entire US consistent so that everyone, honestly, it's so much faster and more efficient. It'll save the country so much money. It'll also make information be able to send things, for example, from Froedtert Hospital in Milwaukee to St. Luke's in Milwaukee, even though they're two completely separate healthcare systems. So I'm going to click all because I just want all the information. So here's what we're going to go through, and we're going to say, now you'll notice that not everything is 0 to 1. Now we're going to require some things. We're going to require identifier, which is called a medical record number or a patient identifier. You've probably heard them if you've ever had a little bracelet on your arm when you walk in the hospital. That is a patient identifier. And you can see that it's going to usually be official. It's usually what you're going to see. Temporary is going to be if you came in through ER and they gave you a temporary identifier because they don't know your name or who you are. You can see that now, if known, they really would like to know your name. So now it goes from name is optional to no, if you know the name, you should add the name. And they're going to tell you exactly how to do that. They're going to go through and they're going to tell you how to encode different things such as telephone and address information. And they're going to do things for the US, which is use a zip code. Up in Canada, they don't have countries, they don't have states, and they don't have zip codes. They have provinces and they have provincial codes. And so it depends on which country you're in, and FHIR is a global standard. So the US is going to say, nope, you cannot use a provincial code here. You're going to use a zip code. Um, so as simple as that may sound, it's easier when someone just says, this is how we're all going to do it, and they just tell you how to do it instead of everybody trying to figure it out at every different healthcare institution differently. We talked a little bit about vital signs. So let's go look at the US Core profile for vital signs. Let's look at pulse oximetry. Pulse oximetry, as I mentioned earlier, is when they stick that little thing on your finger to determine the amount of oxygen in your blood. For young people, it should probably be 99 to 100, but if you're sick, it's probably not going to be that high. So scroll down. We're going to click all again. And now you'll notice everything isn't 0 to 1, is it? Nope, they're requiring things. So we're going to go down to here and we're going to say, here's a code for pulse ox. And they're actually going to give you two options for it. They don't always do that. Sometimes they say you're going to use this one and only this one. But the code that they're going to say to use for pulse ox, also known as oxygen saturation, and if you go look those up in Loink, they're probably pretty close. I have a feeling it's like different ways to obtain the measurement, if I had to guess. But here you can see that they're using Loink, and not only are they using Loink, but they're going to use this exact code. So Loink with this code and the determined and the display name so that you know which one of these two it is, although they're saying they're equivalent and it doesn't matter. So you can either use 59408-5 or you can use 2708-6. And again, it tells you it's Loink. Now you know if you're in an EHR and you receive a lab value with this Loink code, you know exactly what you're getting. And so you don't fill up your EHR with garbage. So when you go to search for it later and you want to display it onto a screen, you know exactly what the piece of information is. Loink has extensive details about how these things are, how this data is acquired, and how exactly what it means. And so it's really important to use an international standard so that you can compare. Should we have another global outreach or global outbreak? It tells you that you need to have a time and date stamp on this sample. That's great because you may have a oxygen saturation measurement from 5 years ago. To be honest with you, no one cares about your oxygen saturation from 5 years ago, probably. But they want to know right now. And so they're going to require date and time. That's great. We're going to go down here for value. And they're going to say here that there's all these different ways to use values, but we're not going to use those. We're going to use value quantity, and it's going to be a decimal number. They're going to tell you exactly how to encode it. And down here, they're telling you it's going to be a percentage. It's a percentage of the oxygen in your blood. So that makes sense. And the way that we're going to represent that percent and define what a percentage is you can go look up this definition at yet another standard called unitsofmeasure.org, which is in fact a standards body. If you don't have a value in there, you need to have the data absent reason. There's a couple different reasons that the data might be absent, but they're going to tell you can only use these ones. Typically, if the data is absent, for pulse ox, I guess the patient might have refused to do the pulse ox. I guess maybe they couldn't find a measurement. That's an interesting one for pulse ox because usually pulse ox is pretty easy. What else is in here? So you can go through and you can read these, but you get the idea. They're going to go through and they're going to tell you that pulse ox is a percentage of oxygen in your blood. It's defined by Loink. You're going to use a Loink code for it. And by the way, if I go way up to the top here, there should be some examples. then they're going to tell you never to use examples for coding, but wow, our example's helpful. So for those of you who are used to seeing things in JSON, you can go up here and you can see the entire resource type. The resource type is an observation, which is a measurement. It has text, so it can describe to the human being what this actually says. The status is final. You don't have very many preliminary pulse ox. It's pretty a simple one. It's a vital sign. And here you go, right there, link code. So they're going to give you either link code so that the system can recognize it. There's two different link codes. We talked about these earlier. It's going to tell you its oxygen saturation. It's going to tell you exactly which patient this is for. The effective date. Wow, this is an old pulse ox. Anyway, this should have a timestamp as well. That's actually pretty poor programming. It's going to tell you who the primary physician is. And then here, value is 99. The unit is percentage of oxygen. The system, as we talked about earlier, is unitsofmeasure.org. And here's the code, %. Now, we are going to have you do an exercise, an experiment a little bit. We're going to have you create one of these. We're going to have you create a bad example without profiling, where you violate all of the US Core profiles. And we're going to send it to the EHR, and we're going to see if you can find it. Then we're going to do a good example where you create a pulse ox object and you send that to the EHR, which follows the US Core profiling. And we're going to show you the difference between the two. Have a great day, everybody.